office. So
there we go. Well, Michael and Aaron, thank you so much for helping my project. Could you go ahead and say a little bit about yourself?
Yeah, I mean, I like physics. I'm good at math.
yeah, so you're just 15. What kind of maths are you studying at the moment?
I think Matthew said it was like second year of university, was it?
Yeah. So Aaron's homeschooled. You're doing a lot of second year university calculus. You've done a lot of matrix and a whole bunch of physics. So usually first year physics at the moment, still working through, and of course studying Python with me. What else are you studying?
I'm reading Guns, Germs, and Steel right now.
That's right. So trying to balance some things, but Aaron skipped ahead a few classes and has always been very good at maths. He could do algebra before he went to school, which was challenging. So, but
that's fantastic.
Yeah. More interest in theoretical physics, though, isn't it?
Yeah.
So not so interested in the real world experiments.
I mean, still interesting, just not as interesting.
Okay.
Are we talking about like quantum mechanics or astrophysics or like, tell me a little bit more about the theoretical physics that has captivated your interest.
I mean, I just like hearing about the stuff. It's interesting.
But what would you like to be able to solve? What big problems do you think you'd like to solve?
Dark matter, dark energy, but like I'm not going to, obviously.
But would you like to contribute?
I mean, sure.
So yeah, you've always had an interest in, how about pure mathematics?
Well, I mean, the Riemann hypothesis is pretty famous, but I mean, I'm not going to solve that again.
Who knows, Aaron?
So
I do.
I have a question for you. So interstellar travel seems like something that's really far off, right? I mean, you can't go faster than the speed of light. It takes so much energy to accelerate things even close to that speed that you probably, what sources of energy could we have? So you're like stuck with generation ships, but then people are like talking about, well, maybe space is actually inside of a bigger multi-dimensional construct, and there's like wormholes that would allow for you to travel completely.
Drives, that kind of stuff. Yeah. So
I was wondering, based upon what you were hearing, how likely is it that you think we'll find some trick that would allow for us to get to another star?
Well, I don't think there are tricks that'll allow us to surpass the speed of light. I don't think so. Warp drives seem to have several problems. I mean, I've heard that there are papers saying that the negative energy can be solved, but I mean, they're still causally disconnected from the outside universe and inertial, and also the insane amount of energy would collapse into black holes. So I find it unlikely that they'll work, and wormholes still require negative energy. So, I mean, generally, I don't think the universe would allow loopholes in something like that. I mean, I'm sure we can find ways to travel very close to the speed of light, but I find it unlikely that we'll surpass it.
Do you think humanity will ever be able to make it beyond our solar system?
Depends on a few things, but if humanity continues to exist and we don't bomb ourselves back to the Stone Age, then yes, we will. But how long, I don't know. I think we have a good shot of getting some small unmanned probes to Alpha Centauri within a few decades, but I mean, Breakthrough Starshot seems to have a pretty good shot at that, but humans in interstellar travel with humans is a ways off.
Yeah, I was just thinking today, in with Apollo 8 back in 1968, what seemed to have shocked the astronauts the most was not the moon, but actually seeing the Earth from that place in space. And today I was just thinking, if we ever do send our first people to Mars, the Earth will disappear for them.
Well, no, it'll be a pale blue dot. It'll be, if they look really hard in the night sky, they should be able to see it. I mean, we can see Mars from here, and Mars is smaller than Earth.
That's true, but don't forget you have this big shiny thing in there between the Earth and Mars at times. So
I mean, it's not always going to be in the exact same. I mean, there's going to be some degree of separation. So, I mean, maybe in the evenings you can still, maybe like in the early night or just before morning you can see.
Well, there's going to be some points in the Martian year where the Earth will be on the opposite side of the sun, completely
it will be
invisible.
Mm-hmm.
But, even if you can see it in a telescope, I got a feeling that, I was just thinking the other day that there's a little bit of flat earther in all of us. We think of space as being something different, but in reality, we're actually traveling in space right now. And I don't think
there happens to be air and ground here in this part of space.
Well, if we had somebody on Mars, we would say that they were in space. But because
what's the difference?
What's the difference? Yeah, but because we're geocentrists, we see it as being fundamentally different.
Yeah. Oh, look, I guess if we want to pivot into sort of the things that I'm interested in, I mean, I love taking. So I've got a, I guess, biggest bang for your buck. I've got an 18-inch telescope, Dobsonian design, and I love looking at far away fuzzy galaxies. It's probably my thing, and it's almost spiritual to me. So when you get out there and you can actually see, and I tend to explore, note down what I've seen, and then come back and then research them. So that tends to be sort of my thing. And what I find amazing is when you've seen galaxies at sort of 100 or 150 million light years away. I mean, that's a long way. And of course, I've seen a couple of quasars, which of course always puts you, of course, I think most people with a telescope can go and see, what is it, 3C273? That's that the brightest quasar. And what is it, 2.7 billion light years away? And that does my head in a really good way. It reminds me of how truly small and insignificant we are, right? Truly small. And I took my mother out. So I grew up as the son of an Anglican priest. Dad's died. Mum still believes very much. And I took her and her friend out to go and look at the universe. And it was really lovely, deep, dark skies. And my mum said that I almost made an atheist out of her. I guess being able to sort of explain the distance between things, and that it's not close, that things are old but finite in terms of, I guess, the age of the universe. So yeah, but Aaron, you've got no interest in looking at things through the telescope, do you?
No. This is a classic father-son thing. I've seen it with my children too. Like, I'm like so excited about space and space exploration, and especially my older son, he's like, you really, I don't see the point in that. We should be working on extending human life, and he's really interested in like the health stuff. But I think the two could go together.
Yeah, look, for sure. I mean, I'm just looking for books now. They're themed. Where is it?
What are you looking for?
I'm looking for my book on the landing on the moon. Where is it? It shouldn't be over here.
What's the title?
Don't know. But I mean, I'll find it in a tip. Aaron, you keep talking. No, you keep talking.
What do I talk about?
Well, I could ask you questions. Did you know that NASA is planning to send astronauts to the moon again for the first time since 1972?
Yes.
And
And
how
they
did you
call it
find out
Artemis.
about it?
Huh?
How did you find out about it?
I think I heard about it on YouTube, I think.
Would you believe that most of the people who I talk to who aren't space people, that only about 20% of them know we're going to the moon?
Okay.
Really?
Yeah. And would you believe that this
Actually, I could believe that, yeah.
and would you believe that that even holds true in Houston, Texas, where NASA's mission control is?
I mean, it is Texas, so yes.
Come on, Aaron. No. People are
It's
people.
even-
You shouldn't classify people based on generalizations.
Okay, yes, but generalizations give good insight into large-scale average statistics,
Okay.
not into individual people.
I would be very interested in understanding what the Australian view of Texans were.
Guns is the first thing that comes to my mind, unfortunately.
Yeah, another one is Republicans.
Well, come on. I mean, I'm sympathetic. Yeah. Anyway, just back here. Oh, have I got my video reversed? Do I need to
No,
go
no, it works
attention-
perfect. I can see it
think that's how-
perfectly.
yeah, no, this is.
I-
It's
So
just-
I don't have mine reversed, but Nathan's seeing it right way.
I see it the right way. The invasion of the
Yes, so
moon,
he-
1969.
he-
The
he's
story of
going
Apollo
first.
11.
Okay, yeah, but I don't
Peter-
have mine mirrored.
Yeah,
Peter Ryan.
There we go.
That's really good. I've not heard of this book.
Yeah, look, it's excellent. It's not a particularly technical version. I bought this for $2. I mean, I love books, and it's quite amazing. It's probably more sort of personal insights as well during the time. I mean, what year was it written? I think it's can you see it when we come in? When was that first?
1969. It was published It was published the same year of Apollo 11.
That's right. Yeah. So, because I'm a 1970 kid, so
Yeah, this book is older than you.
yeah, that's true. That's right.
Well, maybe not this physical book, but the text is.
Okay. I think that this was published in 1969. I don't think it's been reprinted.
It says first published 1969.
But it was made and printed in Australia.
Yeah.
So once again, books are a bit strange. Anyway, we'll talk books later. But yeah, that's a really interesting book. And the invasion of the moon, and it fascinated me. And see, my perspective is that while I admire humans going into space, I see it more from a marketing perspective than, I guess, real science. I think that robotics are sufficiently good these days to be able to carry out experiments remotely. You can send them one way. I mean, everyone cries a little bit when their battery dies, but it's not going to be the calamity of having people perish on the moon or Mars. So I see it as a lot of marketing to put people back, and I don't see it as absolutely necessary for the mission, but it might be necessary to be able to gather the public excitement about going back to the moon and then seeing the possibilities beyond that.
I mean, when they went to the moon for the first time, that was mostly marketing. They did get some good science out of that, but it was mostly about winning the space race, even though, I mean, most of the goals were won by the Soviet Union. Like first man, first woman, first space station, first spacewalk, first satellite.
Yeah.
All Soviet Union.
And what did we watch? We watched the Elon Musk thing. You didn't watch it the other night, but of course, I know. That's right. Well, he's critical to this.
I mean, SpaceX might be, but he is not.
Okay.
Oh,
thank
tell
you.
me more.
He's
Tell
a-
me more.
Elon Musk is basically just a con artist.
Oh,
Really?
He promises a lot of complete bullshit. Hyperloop. Ah, yes. It was patented it's a vacuum train. It was patented 100 years ago, and it's a terrible idea that will never happen. Tesla bot. Do you think we'll have automatic robots? Do you think we'll have automatons everywhere piloting starships? Do you think we'll have humans on Mars in 2024 because he's promised that. It won't happen. He said, Tesla what? It was a mime in spandex. That was his advanced prototype. A mime in spandex. And he promises it by middle of this year. It's never gonna happen.
Well, you know, I can understand a lot of frustration with that. So his ability to predict how long things take to develop is definitely imperfect, for sure.
The opposite of perfect.
Yeah.
It's the worst out of every human ever.
But keep in mind, I work in the public service area, and I mean, my rule of thumb with everything is that get your best guess and then multiply by 3, and it typically works. People tend to underestimate things by about 2/3. That's my experience.
And he also says that using rockets to transport people from one side of the Earth into space and then to the other side of the Earth is a good financial idea. He thinks that.
Oh, and
It's not.
okay, so tell me more. Why don't you think it's a good financial idea?
Using rockets to transport people from one side of the Earth to the other.
Yes.
Rockets are expensive.
Why are they expensive?
They cost millions of dollars. You have to lift someone into space and then send someone and then sends people going really fast.
Well, 747s cost millions of dollars also.
Yeah, but okay. So what's the price of a 787?
Probably 150 million.
Mm-hmm.
And how many flights can that make?
It could probably make, I don't know, 10,000 flights, 20,000 flights.
Yeah. How many flights can a rocket make?
The question is, can you reuse the rocket?
Yeah, sure. How many what's the record for most reused rocket?
I think right now it's right around like 10 flights.
Yeah. How much refurb it needs, and that needs a fair bit of refurbishment, doesn't it? Between flights.
Planes also require upkeep.
Yeah, but nowhere near as much as a rocket. And the rocket still costs like what, 60 million for a flight? Maybe like 20, 60 million for like a brand new rocket.
I think NASA is paying something like 45 million, 50 million per astronaut to the International Space Station. So yeah, but I think Starship is the key, right? Like even with the Falcon 9, the second stage is expended, but Starship will be 100% reusable and could carry maybe 100 people at a time across the world.
I think it'll be for the very rich, but keep in mind, if you look at even the Hindenburg, that was for the very rich, and that's only a century ago.
That was also a terrible idea.
Yeah, that's right. Yeah. But keep in mind, from that we learned, and I guess this is the thing I do admire about.
I think it's.
Did I lose you? Can you? Is it my connection?
Should have been very clear that high.
I'm not sure if it's my connection or
You're back? Yeah.
between. I can't wait until you get
You
Starlink.
literally said that our internet connection is unstable.
Okay, I didn't get that message, so maybe.
So I've got the NASA app here. I mean, come on soon. Oh, there we go. It's black. I love actually just looking through the NASA app. I mean, for me, I'll still go out and look at the International Space Station go across. It's particularly if it's early in the evening, and I love just watching from it. And I do like reading about some missions. I was actually, when the internet first started to have, I guess, images are more readily available. I mean, I think everyone went to the Hubble Space Telescope. And of course, when we got to land the first lot of Martian rovers, I mean, I think everyone went and had a look at some of that grainy, like, I don't know how many frames per second video, but I mean, it was pretty slow. I mean, that was really exciting. Yeah, look, I mean, I guess what's your role? I mean, what do you do? I mean, in your day job?
Well, it's funny you asked. Whenever I started this project back in 2019, space was completely a hobby for me. I worked for a software company and had done that for 25 years or so. Different, I worked at HP, Compaq, internet service provider. Just the whole IT thing. But my kids have gone off to college. One's graduated from college. The house is empty. So now, I kind of relieved from those pressing parental responsibilities. So I decided to take an entry-level job working at NASA to train to be a flight controller to help support the International Space Station. So I just completed 2 months of that. I have about another year and a half of training and work before I actually get to do anything productive. But it's been fantastic. I have a front row seat to people in space, so I'm thrilled.
One of my early reflections, and I'm just trying to remember what year it was. This is maybe 97, 98. Space shuttle flight going to the International Space Station. And I remember actually standing on top of a parking lot because I was on my way back from work. So at about 6 o'clock at night, and it was still quite dusk, but it was bright enough for me to actually see them with some separation. And it was just before they were docking. And of course, it went out of sight before they docked. And I remember writing to Mission Control in those early days of the internet when it was brand new, and they were able to actually tell me which I could see first. So it was actually the space shuttle was on the right-hand side because they were moving from left to right. I'm just trying to remember where I was at the time, but yeah, it was low in the sky. And I remember riding to Houston, and I mean, they obviously had enough time to come and tell me what there was. I mean, I think that's probably one of the great things about NASA is how accessible they are, if that makes sense. They've always been, I mean, a marketing agency in some respects and more accessible. So, yeah.
And, it really kind of makes sense if you think back to why NASA was created to begin with. We have Russia putting up Sputnik, the first animal in space, the first person in space, the, first space, just all these first, and America's technological capabilities is really being questioned. And so NASA was sort of the answer to that. I mean, it really is meant to kind of increase the U.S.'s sort of impact in the world.
Yeah. No, absolutely. What's interesting is we've got a science museum here in Canberra. It's called Questacon, really aimed at, I guess, primary school age kids, maybe up to middle school. There's not a lot beyond there, and I guess I'd never take Aaron because it's well below his sort of intellectual interest. And we were there, feels like a decade ago, and they were giving a talk on space up there. I think they had a small exposition there. And of course, they asked all the questions about who was the first one to send a satellite, the Russians or the Americans? And of course, all these kids said, the Americans, right? And of course, it was that classic thing of going through and naming all of the things that the Russians did first. It was interesting because on that Elon Musk doco, I'm sure you've seen on Netflix. Have you seen it? I'm sure
you're talking about the return to space.
Yeah, I think so. Yeah.
Yeah,
So
I just actually I finished watching that today, and then I watched the inspiration for, I think it was called Countdown, actually. Also,
okay, yeah,
so
yeah.
that was good too. But yeah,
But one of the American astronauts said, I mean, what's the best thing to learn? Yeah, Russian, right? If you're going to be an astronaut these days, so we've got to remember that the Russians are still a space power. It's and I think that space is going to get more complicated over the next little while.
yeah. I mean, the Chinese, for example, just published today kind of some views of Earth that were taken from their space station. And then, you know, Axiom, they sent 4 private astronauts on a SpaceX, but they're also planning to hook up a module to the International Space Station that will eventually become its own space station. And, you know, India is talking about having a human space program.
Yeah.
And, you know, New Zealand, right next door to you, has its own rocket company.
Yeah, absolutely. And funnily enough, just recently, I mean, of course, it sounded like a bit of a joke, but we've now got our own Space Force, which is always bizarre. But I mean, little do people know that, I mean, in the 50s and 60s, I mean, we were launching rockets. I think the second rocket, satellite was launched from Australia. I think it was really early days. So maybe third. Don't know, but we've got some old ones there, and of course we've got some nukes that were exploded in the middle of Australia as well, which was interesting. So, but I actually think that where the initial battles are going to be before we get to Mars, I think that we're going to be, and I think that there are already people thinking about it, is what to do when the US claims this part of the moon. I mean, it's a little bit like Antarctica. So, I mean, at the moment, Antarctica, there's all of these territories, a whole bunch of minerals down there. Chinese have got some space, Russians as well. And all of a sudden, how are we going to prevent people from actually going and mining, drilling for oil in Antarctica? And I think it's going to be even more so when people start carving off, this is the American part of the moon, right? And of course, it'll be all around which minerals, particularly rare earth minerals, which are predominantly found in China. All of a sudden, that's going to have some political ramifications. And of course, who knows if people will start to want to mine asteroids for particular rare earth metals too. So who knows? I think that's where we'll probably bog ourselves down in the next 50 years rather than really going and inhabiting Mars, which will have a whole bunch of brownie points, lots of money spent, but not a lot of tangible return on investment. And unfortunately, governments, because of the debt, I don't think are going to have the appetite for continual outflows of money to support things that don't have immediate ROI. So that's where I see some of it. And what did the US spend? 4% of GDP to get men on the moon? Was that the price?
I think it was something like that. Might have been higher.
Yeah, it was enormous. And I mean, the good news at the moment is that you can still print more money, but inflation's getting out of control. So unfortunately, I think that that's where the politics will creep into some of these things. So I think that it'll be more focused on how do we get on the moon, how do we mine it, and how do we actually bring back some of these rare earth metals. So I think that'll be the commercialization of the moon's going to happen, I think, before colonization of Mars. So,
and how do you feel about mining the moon?
It's going to happen. I mean, it's going to happen. We're not going to go and try and create artificial atmosphere on the moon because it's so desolate. I don't think, and because to create atmosphere would be almost impossible with the absence of water. I think with Mars, I think we've got a greater chance of actually changing things. I mean, I can imagine at some point an Elon Musk type figure will say, all right, let's go and launch a mission to Mars and we're going to go and put some bacteria there. And of course, everyone's going to say, oh, we're going to think about it, but it'll happen. It'll happen. We'll do something like that to go and start creating some sort of oxygenated environment on Mars. But the moon, I think people are going to want to mine it, particularly when they find those first dumps of rare earth metals. I think that because of our batteries, the kind of new processors, chips that will be invented, not from silicon, but won't require other things, particularly when we get to quantum computing. Who knows what kind of resources we're going to need for quantum computing and how to keep things cool or fast. I think at some point it's going to come down to rare earth metals, and therefore people won't ask for permission. They'll just go and do it. And you can imagine, I mean, it's a bit like the Russians in Ukraine. You'll just go and say, we're doing, maybe Norway and whaling would be a little bit more like it, right? Where they go and say it's for scientific research, yet it ends up on the supermarket shelves. It'll be the same thing. We're doing some scientific stuff and we're bringing back 3 tons of rare earth metals to see if they're usable, right? So that's my feelings. So
yeah, that would be interesting. I mean, because the U.S. is trying to create the sort of the situation with deep sea fishing, right? Where the sea and the fish in the sea don't belong to anybody. But if you have a boat and you put a net in the sea and you put it on top of your deck, now it belongs to you.
exactly. So that's how I see space going. And ultimately, I see mining engineers for the moon being the sort of next generation of astronauts. And that's okay. I mean, ultimately, that's the commercialization. And if you think about exploration around the world, it was based on whale oil, right? A lot of that was based on whale oil. Why was that? I mean, energy, right? Necessary stuff to go and light the lights around Paris and London at the time.
Yeah, and it's an amazing thing, you know, I mean, to actually be able to push the darkness away.
Mm. Yeah. So look, I mean, ultimately over the next 1,000 years, I see us leaving the planet. I just don't see us leaving the planet in the next century for real, right? I don't see us having the appetite. Maybe there'll be a couple of missions, and that'll be like the people going off in ocean vessels back in the 16th century. And of course, some of them came back, some of them didn't. There was more appetite then. The Chinese and Russians might have more success in doing that because I guess for the American public, I mean, are they willing to watch American public servants being stranded on Mars? And I guess that's where it's interesting. If they're volunteers, will that make a difference? So I think that might be the tricky thing. These volunteers, and I mean, if you think about Australia's history, I mean, you think about all those Irish and British immigrants who said goodbye to their families when they left to go to the other side of the earth. And
exactly.
Maybe that'll be similar. And of course, lots of them died on the way. I mean, how many ships were shipwrecked? Plenty. The part of Australia where John and I come from is known as the shipwrecked coast. So if you came from the UK and came down Cape of Good Hope around South Africa, Albany in Western Australia, and then you came through Bass Strait, and basically you'd hug the coast, the eastern coast, and around that area, that's where so many ships came and lots of people died around there. So maybe it's going to be the same thing. There'll be an acceptance of that maybe 50% of people will come back, or 50% of people won't perish in space. So, but of course, the other challenges you'd be aware is that going into space is dangerous. I mean, we know that people come back with lots of cancer because all of a sudden the Earth's magnetic field isn't protecting them from I guess, the solar wind and all those interstellar particles. And that's another challenge that I don't think people have truly faced yet, is no point going into interstellar space and having cancer and dying by the age of 40. That's going to be tricky, because if you go back to why are we successful as a human race, it's because all of a sudden all of us have got grandparents who can help raise kids. And if we go into space and don't have grandparents, then all of a sudden we don't have the workforce to be able to really go and do things. And it's interesting. Aaron's talking about, have you read a book called Guns, Germs and Steel?
No, I own it. My son's read it, but I haven't. Just see, it's by somebody Diamond, I think.
Yeah, exactly. Very good. I've got another copy here somewhere. But that's a really interesting one, because you think about
Gerald Diamond, I think. Gerald.
Yeah, he's an ornithologist. Yeah, but if you think about how we developed farming, it was because we had the right grains and could actually do it. One of the challenges, I guess, in, let's say we have a colony on Mars, it's going to take a lot of time for them to be able to actually get to a point where they're receiving more energy from the planet than they're putting into it. So I guess that's, how long is that going to take, and how many lives of energy is that going to cost? So it's a 100-year program, if you could sort of conceptualize that, and how many people are going to die in that 100 years. And because politicians, I work in healthcare. I mean, one of the problems in healthcare is that we can't think beyond sort of 3 to 10 years, where realistically we need to think about 100-year problems in healthcare. But because there's no votes in 100-year healthcare, we end up keeping on returning to 3 to 8 or 3 to 10-year programs. So
there's no money in health. There's only money in sickness.
Yeah, that's true. Yeah, exactly. Yeah, very true. Very true. Although for Australia, it's interesting because of our Medicare, because we pay tax, and most healthcare is determined by public spending. There's a little bit more focus, I guess, on preventative healthcare, and I guess a little bit more efficiency, particularly in, I guess, public hospitals. Yeah, there's money for private providers with general practitioners, with primary care, but on the pointy end, we're actually really looking on how we can actually start controlling some of that spending. But once again, in 3 to 10-year cycles, rather than, I guess, longer term cycles. For space, this is where politicians are going to have the appetite, because it will come out of public funds. And how do you get people to focus on something that's going to be achieved by the time you're well and truly in the ground? So I see that as being the next challenge. And of course, we find that people have great difficulty coping with climate change in terms of spend now to reap in 100 years' time. I mean, what's in it for average Joe? So how do we actually change that? So there's some of the challenges. And I think that that's where, if we come back to the original problem, the commercialization of space needs to have some sort of return on investment. And already NASA's let in private providers into launching rockets, still paid for by the public, but ultimately there'll need to be some more return on investment for government launching things. So that's where I think it's going to be off the back of commercialization, and hence the parallels with searching for whale oil.
No, absolutely. And, you know, just coming back to our previous conversation about NASA and the marketing thing, what challenges does it present to NASA when it is no longer the sole brand on kind of these innovations? And, you know, I mean, it's, you know, it's just kind of interesting situation.
That's right. Well, I mean, obviously you work private enterprise with IT. I mean, brand's really important thing, isn't it? Yeah, it's diluting your brand with other providers, even though you're in theory where the source of money is coming through, is interesting because you're selling things and they're profiting, and you've got to think about profit. I mean, so who knows? But I see space tourism as something that NASA might have missed out on.
Absolutely, and ironically, the Russians seem to have been a real above, kind of going back to actually making it happen. I heard like Dennis Tito, like the first private astronaut, if you will, that flew on a Soyuz to the International Space Station. At the time, NASA was not really accepting of that, and Russia is like, well, we have our own parts of the station, we can do what we want. And they're like, well, okay, he needs to stay in your part. Whenever that is really something that we should have been embracing.
Yeah, I mean, particularly for the US, I mean, capitalist country on earth. I mean, it's always a bit bizarre sometimes. Yeah, so, but look, your day job. So, I mean, what do you need to study when you're there? Obviously, a lot of communications theory as well. But what else? What are they putting you through in terms of courses? I mean, I guess there's theoretical and practice. What's the theoretical stuff that they've got you doing?
Yeah, almost no theoretical stuff for us. So we're on the operations side. Very light on the foundational pieces and a lot more on how it's implemented, how to make it run. The team I work on is responsible for the station power and the external thermal control systems. So we manage the solar panels, the battery charging, making sure we don't overload anything, figuring out things whenever we do, trying to protect the solar panels, the batteries, the other parts, making sure everything stays at the right temperature. So I'm only 2 months into my training. We've just done like the overview things that everybody gets, what's the science that's done on the board, how do we get the astronauts safe? How does the communication systems work? What are all the software that we use to kind of manage everything? How do you actually send commands up to the International Space Station and make it do things? Getting telemetry and that type of thing. But starting next month, we start really deep diving into the electrical power systems and that.
So you work alongside the engineers with the real world models of what's up there so that you can actually know what's going on? Because my understanding of NASA is that you've got basically everything backed up so that you can actually fix it here and work out what's going on.
We do have a lot of simulation, software and physical. So we do have a lot of, pretty much everything that's on the International Space Station is here in some form to be able to work out issues like that.
Yeah. And this is one of these things where you've got to know 100 times more than what you actually use, kind of thing. Is that?
We hope so. In the simulations, everything's falling apart, and we have to still save the day. I think the goal is that you will never have a worse day than what you have in a simulation. That reality will always be better. That's the goal.
Yeah, understand. Funnily enough, I mean, working in healthcare, I mean, they had all of these protocols in place for what to do with COVID. And of course, all the manuals were thrown out the window and they began again when sort of COVID hit. It was a little bit nuts. So I think healthcare probably needs to take a leaf out of your book. They certainly didn't plan or train for COVID sufficiently. So yeah, interesting.
Yeah, and particularly which part of that book they should take a play out of. We have this thing called flight rules, which are constraints and definitions and pre-made decisions that are made before they might ever need to be made, but without the pressure, able to take your time, get a whole bunch of people to provide input, and whenever you get in that situation, you already have sort of this pre-thought out thing. It may not fit your situation precisely, but it's a lot better than trying to do things on the fly where you can only look at the stuff that's right in front of you and not understand the downstream consequences.
Yeah. What was interesting with my role is that I was doing a lot of the mathematical modeling for COVID early on. I mean, once again, really depended upon a lot of stuff published out of the UK based on China. And we had a lot of time, a bit more time to think, but of course we were watching what was happening in Italy at the time. And one of the things that was formed was a 3-person ethics committee that would start making decisions. But I was working with a really clever guy. He's one of the cleverest data scientists in the world. He works at the local university. And we were talking about the kinds of data that could come in to then be able to make automated decisions upon who might get the next ICU bed. And that was interesting to work with him because he'd thought through some of this stuff. And of course, the ethics came in, which was the trickiest part. For instance, do you bring in people's country of birth? Should you be able to discriminate on people? Because of course, we know that particular groups of people from ethnic backgrounds have got different susceptibility or survival rates from COVID. So that was probably my first exposure to really hard decisions. And I mean, this is where I'm sure that you'll probably have some courses in ethics where when you've got to make decisions that have got principles behind them and may have to be involved in human life. I mean, you've seen all of those questions that they ask, I mean, of AI. You're traveling towards an old man or a group of children. I mean, same sort of questions. I'm sure you'll be involved in it if we go and do much more complex missions, surely.
Yeah, no, it's really challenging. I mean, at a high level, we kind of have a prioritization of crew, vehicle, mission. So that's kind of like the order we operate in. We haven't really gotten into much of, kind of, if you had to make decisions within inside of each one of those buckets, right? But
yeah, but see, all of a sudden you go and put volunteers on a mission to go and mine an asteroid, and one of the big companies has put up money. Maybe the priorities are in reverse order for the company.
No, that's true. That is a challenge. And yeah, I mean, that's kind of always been a challenge. I mean, I think one place that kind of that relates to your field is around, human testing as something. You have these people that hope it's going to fix them somehow. But what's even crazier is, and both of my sons were involved in a vaccine study.
Okay.
So we got them involved hoping, that they would get protection earlier on. But there's a very, your odds of getting the vaccine in a study is close to 50-50.
Okay, yeah.
And the way they know when to stop the study and look at the results is when a certain number of people have actually gotten COVID or gotten the disease, to then go and see, well, was that predominantly in the unvaccinated part or the vaccinated part, or was it evenly distributed, kind of type thing. And so, that's kind of a funny situation to be in,
Yeah. By the way, you probably worked out my son Aaron's got autism. One of his jokes is that vaccines don't cause autism. Autism causes vaccines. Right?
I like it. I love it. I have a friend who has an autistic son as well. I'll have to see what she makes of that joke, but it's a good one.
It's a good joke. Yeah.
And honestly, I didn't realize he had autism. So.
Oh, really? Okay,
yeah.
He's an unusual guy. By the way, this is the great privilege of living in Canberra. So on Tuesday night, we're off to ANU, and there's a free lecture there with Brian Schmidt. So 2 Nobel laureates are speaking at the same time. So yeah, we get an hour with 2 Nobel laureates, which for an Australian university is pretty good. So we've got Peter Doherty, who is interested in, what's it called? Plagues physics? Where is it? where is it? Anyway, yeah, so they're going to be talking about theoretical physics, in particular cosmology, and talking about Brian Schmidt's discovery the universe is accelerating in coming apart even faster. And of course, Peter Doherty will be talking about COVID probably, but we'll see what they talk about at the time. So yeah, we're really fortunate here in Canberra, so it'll be good.
Yeah, no, it's good that, you know, you could go to a place and really judge it by how many bookstores and what type of bookstores you have, you know, and having like lectures like this to bring people together to just, you know, kind of think about these things. You know, I just feel like we have 8 billion brains on this earth. And I think the percentage of them that are actually involved in moving humanity forward in any meaningful way is probably quite small.
Yeah, that's it's very true. I mean, I work with a lot of people who do their day job. I mean, realistically, they don't clean up anymore. I mean, my philosophy on the earth, even though I'm an atheist, is that you've got to leave the earth cleaner than you found it. I mean, it's like if you go camping, right? You go around after you've finished camping, and then you'll pick up even other people's stuff. You should leave a place better than you found it. And I guess I take that to my work as well. I mean, I won't be able to solve healthcare. I mean, I think a decade ago, I guess I was idealistic enough to think that I might. But ultimately, I just want to leave it in a better place than I found it, with a better platform, a better understanding of the things that we can change, and enable some people to actually do some things better and at least keep us moving down that path. So I guess that's my philosophy. I think that the proportion of the people who actually leave things cleaner than they found it is less than 50%. And in Australia, if we want to talk about politics, we've got more than 50% of people in Australia who don't pay net tax. So one of the problems we've got now is people living on the government's teat. And of course, that's shifting us further to the left. Rather than people looking to themselves, we've got now people looking to government as their first call. And I think we can also judge a society about how it looks after the most vulnerable. But this is always the question back to NASA. I mean, why are we spending billions of dollars flying things into space when we've got still people living below the poverty line? And it's a tricky question. I mean, and ultimately, mankind does benefit. I mean, if you look at the percentage of people living in poverty over the last 50 years, it has declined. Now, why is that? Why is that? People,
Yeah, I mean, it's just, I mean, if you look at how we've been able to increase the productive yields of land and being able to get those foods to markets all around the world, I mean, if you have some type of crop failure in some part of the world, it's an inconvenience. It's not a catastrophe. At least if you live in Australia or America.
Yeah, that's very true. I mean, and I guess I wake up every day and you think you breathe and I'm alive. And I mean, I wasn't born in such and such country. I mean, it's yeah, I'm glad I wasn't born in Ukraine at the moment. Yeah. So, you know, look, I'd love to keep in touch, Nathan. I mean,
absolutely.
Please. And look, thanks for the WhatsApp message. It came through easy, so that was great. And look, happy to talk. And of course, if you ever come to Australia, I mean, I'd love to take you out and show you the Southern Hemisphere stars. I mean, that'd be amazing, particularly the Milky Way from what you can see down here. I mean, I think you can see from Texas if you're really in the south. I know Houston's a little bit further north, but if you're in the absolute south of Texas, I think you can see the Southern Cross if you're really lucky. Just across, but I was fortunate. I lived in Switzerland for a few years, so I didn't look at anything in the south. All I did was look at things in the north while I was there. But I didn't have as big a telescope as I do now. But that's where on my bucket list is to be able to go and see and spend a month really looking from dark skies using a big telescope. And Hawaii might be the best chance there, I think. So
that would be nice. Yeah, in the middle of the Pacific Ocean, away from lots of light sources.
yeah, absolutely. So I mean, have you got any dark skies where you are?
We have a few, you know, in like the West Texas area. We have the McDonald Observatory, might be big enough to for other people to be familiar with, I guess. But yeah, we do have in some places, not around Houston. Houston
Oh,
is
clear.
very,
I can't imagine what that's like. It's
yeah.
Well, look,
Occasionally,
Nathan,
okay.
look, see you, Nathan. An absolute pleasure meeting you. All the best to you and your kids. Right.
Okay, thank you so much. Talk to you soon.
See you, mate. Bye.
Bye-bye.